Basically, this is kind of what you've started already. Is you've created a UI with some kind of object, and what I did was I created a script that just takes a list of prefabs, takes a list of names. It automatically generates the buttons for each of those prefabs. As you can see there, it's filling in. It's obviously time delayed. I use a coroutine there to time delay it to make it fill out. And then all I have to do is select one of each of the buttons and that thing will show up on top. And I can change the number of items in that list by just changing strings in a list. And it will reference a different prefab or change the order or whatever I need to do.
So when you say it's a list, is that an array?
An array is kind of like a list. They're very similar. Basically, a list is a more modern data structure with some extra features wrapped around it. It's still kind of an array underneath the hood. And we can see that the script here, this is the config base. Whoa. Config base is just this guy. And it has this item selector script. And here are the list of prefabs that I created in there. And those are referencing things that are in my resources prefabs directory here. But these are just strings at the moment, so I have to make sure I type the name correctly. But I could change the order if I wanted to and put sphere down here.
Could you drag and drop from the prefab resources folder into those?
No.
No.
I could set it up to be that way, but right now it's just a string. And Jerry's going to set up the Vive up here since we're having trouble with the Oculus controllers. So we can work through this and actually test it out and stuff. But to begin with, let's do the, let's go through the exercise, the homework 1 exercise, or the exercise and homework, exercise 1 and homework. There we go. Let me pull it up. All right, so I asked you to watch 2 videos, the enumerations and the switch video, and then create a new method that accepts an enum named location and returns a string. So let's open a new project here. We'll just use this one we're working with this morning. Opens on the other screen. Yeah. Okay. So the first thing it says is to write a new method. So we need to create a new method. It's going to accept an enum named location and it's going to return a string. So we know its return type is string. It doesn't say what to call it, so we'll call it location tester. And it's going to accept an enum named location, which we haven't created yet. So let's create our enum. I think most everyone was able to do this part. We want to create an enum that has, it's called location. And you can see that then completed this guy over here. So now it knows it's an enum named location. There's Earth, Mars, asteroid 56, Space Station 2, and Colexivon Gamma. Some kind of nerd made these up, I guess. All right.
Why is that not a public enum?
It can be public if you want, but right now we're not using it outside of this class. So if we wanted to use it outside the class, it would need to be public. Right now it's only available, the scope is limited to this class.
That's a question about enum. It's similar to a list or an array. What is different about it that we're using an enum instead of an array or a list?
Well, so kind of under the hood, this is, it's really just a list of integers. And each integer is assigned to a name, or it's not really a string, but it's a name. So it'd be kind of like creating a list of variables with integers.
Which is basically what an array is, right?
It is, except it's not as easy to pass in, because you want to limit it to only these names right here. If you had an array of integers, you would pass in something like an int to evaluate, and that could be any of the ints available. So if you had something like an array of ints, we called it my locations. Okay, an array of strings.
And string square bracket 0 would be the first element.
Right.
Just like, I guess an enum 0 would be the first element. They both actually have integer, they're integer based, whatever you call them.
Indexes. So that's, or fires, whatever.
Containers for multiple objects. They're both integer driven. What is different about one of these using an array and then still having integer based?
Okay, yeah, so if we had this is an array of strings right here, right? We can fill in the other ones, but it's not particularly necessary for this example. So when we wanted to evaluate one of those, the only type available to us is string. And that could be any string that you can make up. Whereas this enum is limited to these values only. So when you're making your switch statement, for example, you know it's going to be one of these values, unless it's been modified later on. But does that make sense why you'd use this instead?
It does.
Okay. It's a quick way to switch between different options without having to go through a lot of checks to say, is this string inside of this array of strings? Therefore, it's a valid string. Now we can look at it and decide what to do with it.
Are they okay to have different type, or they have to be the same type? Mean both.
They're all of the same type. They're all an enum location. There's no other type information associated with them. Yeah, we're kind of assigning a string to them by using this switch statement to return a certain value. There are other ways you can manipulate enums to associate data with them, but for now we'll just keep it simple. So we have our enum, and we have a method that takes a location and returns a string. And we knew we had to use the switch statement, so we're going to do a switch. And we're going to switch on my location because that's the thing that we're deciding between. This is basically, it's a multi-branch system where you're putting in some input and you've defined this list of outputs that are available to you. The switch statement is then defining all of those outputs. So we can see that when we start writing our cases, it's going to prompt us already with location. And then it's going to give us the available options. This is, again, limiting those available options to just what's defined inside the enum. So in the case that my location is equal to location.earth, This is similar to saying if my location equals location dot earth. Right? We can write these at the same time, and we'll see how they're very similar. In that case, we're going to return, we're supposed to return home sweet home. ASCII is one of the programmer's nightmares. There are actually different kinds of quotes. You may have never noticed that before.
I had that problem where it was just not working for like a half hour, and it was just my quotes.
Yeah. They look they look almost the same, but the quotes, there are different quote characters inside the ASCII table. If you're familiar with ASCII, you've probably seen ASCII art or something like that before, but that's...
How do you spell that?
ASCII. It's abbreviated from American Standard Code for Information Exchange. The ASCII table, they look something like this. They're basically, it's a mapping between some kind of decimal value and a character. So we have all the letters, 65 through 90 is all the capital letters, 97 through 122 is all the lowercase letters, and there's all kinds of other characters available in there. But for example, there's one type of quote there. This is the base ASCII, and then there's also extended ASCII because they wanted more. These are the kind of the things you'd see in the old time consoles where they use all these characters to construct a table and make it look pretty. But there's either another quote somewhere in here or something in a more extended ASCII, something that Chrome recognizes as a quote character, but Visual Studio does not. So if you find that, especially this is, if you find that you're getting errors like this, the string should be a different color than the rest of the code, so that should be a hint. And you might even have one, and you'll see that anything you write after this is also still a string, and that doesn't make a lot of sense. So something to watch out for. It'll also be with single quotes, you'll see that. All right, so then our case location Mars. And our string. And this would be the same as, well, this goes here. Else if my location equals location.mars, and return this. So you can see how the switch is kind of like a shortcut or a cleaner method of doing all of these if-else-if statements. You can imagine we'd have for all of the locations here, right?
So in the example on the video, they had instead of case location dot or dot whatever, they had like just case 1, case 2. It's basically the same thing.
Yeah, because remember, underneath the hood, these are just integers. And you can see if you hover over it, it says location.earth equals 0, location.mars equals 1.
So could we have written case 0, case 1 instead?
You could, if you did a, let's see here, could cast, it looks like it casts automatically, or you could cast this to an int. Yeah.
In the tutorial for switch statements, they had break, which
Yeah.
I think they said was to make sure that it didn't go down the line of all the different
That's right.
actions. So
Yeah.
here we did return, which makes sense because we needed to return a string. But does it run through all of them, or
Yeah, let me show you what the case would be. So if we were defining some string up here, and then instead we were just setting that here. And then we had some default case down here. So what this is complaining about is that the control is falling out of the bottom, and what that means is that if you didn't return, so let's see if we can break here. If you didn't return from, if you didn't break out or return from a certain case, it's just going to continue on to the next case. These are basically just labels that say, depending on the location, jump to a certain spot in this list. So if my location is equal to Mars, it's going to jump to this location and then start executing code from here. So if you didn't then also have a break, then it's going to continue on to the next and next until it gets to a break or a return. And sometimes that's useful if you had two cases where you wanted to return the same thing. Once humans expand to Mars, for example, we can change this to in both cases, Earth and Mars will both jump to here and set the value to that.
Which makes that an OR statement, right?
That would be kind of the equivalent of writing an OR. Yeah, you're right. Okay, so the switch is really just the split in the road that says, if you're this, take that road, if you're this, take that road. And some roads might lead to the same place, but they're still going to be slightly different starting points. Even if you got to location Earth, the next line to be this is just going to be ignored in the execution because there's nothing to do there. Yeah?
So should we look to this script when we already made our view room button for returning different objects on a button click? Is this something that would be useful?
Something like this could be useful for that, or you could do switch statements can be used for different control schemes, or like it's basically just anything where you want to have a lot of different branching paths and you want an easy way to refer to those without having to say if this condition, else this condition, else this condition. So it's just a way to I mean if you're it's all about control flow, right? We have we have one road of code execution path that just steps down. And the tools we have for controlling that, we have loops that we can turn the road around and come back on itself. Or we have this guy, which is a branch that will branch out to multiple ways. And then those can either come back to the center and then continue execution, or they can go off on some other wild tangent or whatever it may be. It's all about building up that path to be this sequential order that makes sense for the code you want to write, the steps you want to take. Okay, does that make sense? Does anyone want me to fill out the rest of that, or does that make sense? Yeah. And that was it. It just had to return the value at the end. And then you could test this in the update method here. With a location for Mars or something. Okay. And that would just output actually in this case it output the same string. And if we used any of the other locations, then it would output, I don't know that location. The default is required to have because you have to have some, well, in this case, we wouldn't need it because we're setting this empty string, and then if our switch doesn't match any of the cases defined in here, then it just skips over the entire switch statement, and we'd return an empty string. If we were doing our returns from inside here, then we would need a default value, or we would have to return something outside of the switch statement here. Because otherwise your method doesn't return a value. All right. Let's see.
So how did you trigger it in the start function again?
I did a debug log, and then I called the method, passing in some location.
But since it returns a string, do you have to do a debug log, or could you just?
No, you could do this. Just the return string would go into the void, into nothingness. But you could, if you didn't want, if you were performing some function here, this could be void, and you can just switch on my location and say, in case of Earth or Mars, I don't know, you could have like a shutdown method. Otherwise, you could have a load app. You could call methods in here. It doesn't have to return something. It can just be a conditional for all these different options. What do I want to do? It's just a branch, right?
Theoretically, they should be working in 3.
Where's the lighthouses? Did you set those up? Oh.
I didn't have room.
All right.
You're so cute.
Uh-oh.
There goes my lighthouse.
It's just a motor spinning at like 7,000 RPMs. I'm sure it's fine.
Yeah, this is my personal one too, but that's cool.
Oh, I don't know. I imagine they use like a standard hardware, and one of the standard hardware would be the motors for a hard disk drive, which is 7,000 RPMs is the typical. So that's my guess. I don't know for sure. Ooh. Should be able to see each other. We'll see if this works. I just need one for now. That's fine. Alright, let's see if we can load up this bad boy. I got a little carried away with my project. You guys, you're not expected to do the programmatic generation of like using coroutines and stuff. I'm going to show you that stuff just because I think it's cool, but you're not required to use that. And you'll have access to this code as well, so you can. It should be easy to implement if you want it to. This is not in the shared project yet. I'll put it in there though. I'm just going to demo from this project right now and then switch to the shared project and rebuild it here to show you guys how it's built. Not initialize OpenVI. Oh, we maybe need to change this. Oh yeah, okay, really like this. Probably. I've never used it without Steam installed before. Bum, 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 bum. One moment, please. So today we're going to look at creating UIs a little bit more. We're also going to look at making UI prefabs, so making the UI itself kind of dynamic. And then we're going to look at events because we want to be able to hook up our controller events. And we're going to look at something like a click handler, so we know when the button has been pressed from far away. There's no easy built-in, well, I guess there's easy ones because they come pre-made. Some people have Git repos of pre-made interfaces and stuff. We're going to kind of build our own just to see how it's done. And I think I've found one of the simpler ways to build your own. It's maybe a little hacky, but it's the cleanest implementation I've seen. So. Easiest to understand anyways. Updating Steam. Just going to check the sales real quick. And then now would be a good time to get any Steam, any VR games, during the sale here. Although probably my favorite app for VR right now is the Google Earth VR. If you haven't used that before, it's awesome. Google has used, they use satellite photography, top down, and then they use aerial photography from 4 directions, so they get that 45-degree angle. They combine all that data using computer vision, machine learning, artificial intelligence, all that type of stuff, to build up these 3D models, 3D textured models of all the major cities in the world. And so you can put on your VR and you can walk around Portland like you're a giant and look down and look at all the buildings, and it's kind of like walking around one of those super detailed train set models that people make where they put all the little people down there and everything, but very cool. Definitely worth checking out. And we have the vibes here, so it's a free app, so worth checking out. Password. Right. Two-factor authentication. It's awesome. Ooh, big. All right, so that's installing Steam VR. Just set it here for now. Yeah, so if anyone uses a Vive a lot for development, it's a pain to take it on and off all the time. I ordered this, it's this Kickstarter project that is a new, you can replace the head strap on this by swapping out these guys. And it's a more balanced headset that makes it a flip-up display. So really cool for development because you're always up back on the keyboard and stuff. So very nice. I haven't got it yet though. Yeah, it's Kickstarter, so we'll see. All right, well, we'll demo this in a bit. For now, we'll switch to the shared project and start looking at UIs and UI prefabs. All right, so I'm gonna just try to start a new scene. We'll name it. Our VR room. Remove that one. Add the prefab camera rig. And then add a floor. People like to see a floor when they put it on VR. It can be disorienting otherwise. Depending on the situation, you could drop out the floor for a little scare. But if you're into those type of games, oops, you want to create the thing at this level. Alright, so let's see, first thing I want to do. So let's just create one of those spawner platforms or whatever you want to call it. Let's create a cube. And I'll change the scale. I'm going to create a parent object for this because I'm going to have multiple things, the UI and this platform visual representation, and then I'm also going to have another empty object telling me where I want to spawn things, which we'll see in just a little bit. Spawner. Okay, and then we're going to create a UI. Let's start with a canvas. I'm going to make that a world space canvas.
Is there any problem with renaming the canvas?
Nope. Objects are defined by their components. So you can name it whatever you want, as long as it has this canvas element. This canvas component right here.
I seemed to run into problems with it, but I couldn't identify whether the renaming it was the problem.
Well,
I'll spend more time with it.
So people can get sloppy in their scripts, and they can just try and find objects based on their name.
Right.
And you might, if you had something that was finding it by name, then you could get into trouble. None of the Unity stuff should do that. It should be fine just to rename it. I mean, we'll name it. Item list canvas, for example. We'll make it a world space, and then we're going to change the scale. Probably smaller than that. I'm just positioning it so it's going to be in front of, let's change this actually. So it's going to be in front of that pedestal. I'm going to scale it down just a little bit more.
Sorry, was the spawner game object just an empty object?
Yep, that's just empty game object. That's just a container for all the things I'm creating. So that if I want to move it around, I can just move around that guy. Everything goes with it. Okay, and then underneath the canvas, going to create a new UI element of So what I'm going to do is I'm going to show you how to do that dynamic button generation. And what we need for that is so we have our canvas, and now we're going to make a panel underneath that canvas that's going to contain the buttons. So this is that hierarchy thing. You're familiar with web development or something like that. This is like the nested divs where we're containing objects inside of the higher level objects. And there's also another reason we're going to create it as a panel. And that's because there's this, so we don't have to, in our scripts, we don't want to have to manually position all the buttons so they line up nicely, which can be a pain. But there's a component underneath layout that's called the vertical layout group. And that's just going to take all of the components, all of the UI elements that you stuff in there, and it's going to organize them vertically, top to bottom, inside of this Rex transform. So let me size, we'll call this our button list. And we'll change the size of that so that it just kind of takes up the front of that pedestal. Yeah?
I had some trouble getting the transform controls to appear. I watched the video and I saw you were able to do that, but did you have to select anything?
I did. So there's this tool up here. These are different tools for modifying things in the editor window. And if you're just using position and scale and stuff like that, it's not going to work very well for UI elements, but there's this, I forget what it's called. It's a UI, it's for UI elements, a manipulator for them, which gives us these handles.
So your canvas, it doesn't have to be the size of
the canvas doesn't have to be the size. This is just this is the screen. The canvas is the screen, and this is just a window on the screen. So when we add a button to this, button. We want to, so in our vertical layout group, we're going to control the width of so this will set the width to the same width as the layout element. We can control the height too, so that it's always full, and these buttons will just get shorter and shorter as we go in. I like to just leave it unchecked. I did a Control Z there because otherwise it sets the height and then leaves it. But
What are the benefits of using a panel to put your buttons on?
yeah, so for example, now if I
Hey Michael, since the text on it is so teeny tiny, is there any way to make the Unity viewer bigger? Because it's super hard to see.
It's hard to see.
yeah, let me see what we can do about that.
It's hard to enlarge in.
How did you do that? I'm sure it's hard to work on, but it's easier to see.
Yeah. Is that easier to see?
How did you increase it, the size?
So I went to the display settings. In display settings, I think they introduced it in Windows 10. There's this scale. I just up that to the maximum. You can also change the resolution if your monitor supports that. Some lower resolution would make things appear larger. Okay. So let me get my bearings again here. Right.
I think we can see it. Was there something you were doing, properties of the button where self-size or didn't?
Yeah, so in this panel we created, we added this, whoops, that's the canvas, the button list. We added this vertical layout group script. In there you can control the child size. That's any child that's in there. You can set the width or the, it's cut off right now. It says hide, but this is, you can control the width or the height. And the reason you want to put it in a panel is because when you add other things later, it will automatically arrange them.
And otherwise, like, you just have to
yeah, so let me undo that. And if we didn't have this vertical layout, when we add these buttons, they're all in the same spot. They're just on top of each other, so we have to move them all.
Okay.
Well, we have to move them all into position, and then if we wanted to add another button, we'd have to move and scale everything again. And so this container for them allows us, you could make the entire canvas a container, I suppose, if you wanted to just use the canvas as your top level.
Which is basically what I did.
Yeah, this is, I think it's a little cleaner to do it this way, because you can then have other things on the canvas if you wanted to, or whatever it may be, or you could reuse this button list somewhere else as well.
What kind of object was the button list initially?
It was a panel, and that's just in the UI panel.
And the script is just, it's in add components under layout, right?
Yep. The vertical layout group. There's a UI category, which is a little misleading. This is UI elements, but the layout is all about UI elements as well. It should kind of be under UI. It should be UI layout, in my opinion, but this is how they've set it up. So layout has various components for UI elements. You can have a horizontal, there's a grid. Oops, you can only have one layout group at a time. So we could do like a grid layout, where they're a bit large here. If we did like a 10 by 10, maybe that's too small. 25 by 25, see these, now they're cut off to say but just identify the juveniles. Identify the juveniles, uh-huh.
I'm guessing the layout, things, both the UI components can be in the layout.
Just UI components. Well, anything with the rect transform instead of just a transform. So we'll change that back to a vertical layout group. Control the width.
You couldn't have an image in there that was not.
You could have an image if it was a. So if we added a UI image here. In fact, a button is just an image. You can see if we look at our button, it has the image script right here. It's just an image with this special image in the background that gives it that border around it.
So it's like a pre-made image or whatever it is.
Yeah, it's just a pre-made built-in Unity thing that says it's going to have these components. You can make your own. You could start with a empty object inside of here, and if you create it inside of a canvas, that's going to automatically give it a rect transform instead of a transform. And then you could add all the components you need to make an image here as well. But the Unity just gives that to us built in. So a button is just an image, and it has a text element underneath it with some text. And it has image script, and then it has this button script, which is what handles the clicks. Yeah. So let's set up our button. This is done downloading. Let's try that out real quick. Oh, first time setup. So inside our resources is where we want to keep all of our prefabs. So I'm just going to open up that directory to make sure it's available. And then this button, we can drag down to here. And that'll create a prefab, just like we created a prefab of that cube before. Now we have a prefab that is a UI element, which can then be added to here as much as we want. So that'll be, and we'll do that via script so we can automatically add those buttons. See if this is tracking it. through the setup real quick. Yep.
If you edit a prefab, are all instances of that prefab in your scene updated, or do you have to re-grind it?
They will be updated if they are still linked. And you can tell they're linked or not by the color of them. They're blue. And you can even update if you had a prefab in the scene and you changed something about it. We can change the height on this guy. And then there's this prefab menu here at the top of the inspector. So if you change something in the scene and you want to apply it to all the other prefabs, you can just hit apply here, or you can revert it back to what it was, for example. That doesn't seem to have worked. But you can change the height and apply it to all other prefabs, and now this button prefab down here has the same height as we just set here. That make sense? Sorry, just setting up. Place your headset on the floor. Oh, on the camera. Yeah. Okay. Two audio listeners in the scene because we have this main camera here. Oh, and there's kind of a bug right now with SteamVR. Let me pull up the solution for that. Sometimes, if you're using a Vive at least, I'm not sure in the Oculus because we couldn't get it to work anyways. Sometimes when you start up with the Vive, the controllers won't show up. You have to manually enable them. But there's a script you can add. Which is loading. SteamVR update poses. So if we go to our camera rig and we add component of SteamVR update poses. I'm not sure what that script does exactly. I'll share this link in the Slack, but when we add that, let's see if that worked. Yeah, controller's somewhere around here. Not showing up in the right spot. You can see its shadow though. It's probably because how the lighthouses are configured right now, but we're going to need that in a little bit. Oh, doesn't appear to be working exactly right. Oh, there we go. So, do it out of here. Now our controller's working. Still not showing up though. Let's see here. Well, we're going to have to readjust the lighthouses to be farther away. Okay, so we've created our button prefab, and we have our button list. We can delete the existing button that's in there. And we can create a new script here. On the empty spawner can hold our script for this. Let's see, we'll call it item list manager. You're going to use like manager, and there's so many common words that you're going to use in all your scripts that they're going to start to look alike, but that works for this situation. It's a manager. Okay. Well, now that this is large, we can probably reduce the font size a little bit. All right, is that good for everyone in the back? You see that? All right, so we have an item list manager. And we have our list. This is our spawner. What do we do with our spawner? Oh, it's just that. That's fine. All right, so the requirements for our item list manager are to take a list of prefabs and create buttons for all those so that we don't have to create them ourselves. So we know that it's going to have a public list of, we can do strings for now, and we'll call that our item list. Okay, and that'll then create in Unity, we'll have this item list. And this is kind of where the array becomes a lot more apparent, is that they don't have a very good, like a lot of the things that you look at in the inspector look very nice and are very intuitive. For a list, you have to just manually set the size of the list, and that'll give you that number of elements in the list. So we can, if we look at our resources, right now we just have cube, but.
Can we go back to the strip for just a second?
Yep. This is in the shared project, so it's going to be committed to the source as well.
So, just trying to figure out like why you chose those particular terms.
Okay, yeah. So a list is a data structure for holding a list of objects. And in this case, we want it to hold a list of strings.
Which is, because of the brackets, it's a generic.
Yes, it's a generic. So this means that
Just a generic.
just a generic.
Okay.
Well, it's in this case, it's a generic data structure or something. I don't know what you call it exactly. So you can actually see it's in system collections.generic list, and it just means that now when we do something like item list.add, it's going to ask us for a string instead of whatever else. Yeah, if we said we wanted a list of integers, for example, when we went to add, it's going to ask us for an int. This is just a way of telling it what type we're going to be storing in there so that it can appropriately type check and request the correct types and all of that. Getting cold in here, or is everyone leaving?
Like, I'm not.
And so you're telling it that it's just a new list.
It's a new list. Yeah, we're saying new list. Technically, since it's in the inspector is going to create. It's going to create it new itself because it's public. If it was private, we'd have to do this new. It's just good practice to say, I want a new list. Otherwise, when you try to access this thing, it would say, item list is null. You've created the bucket, but you haven't put anything in. And so we need to create, it's kind of a bucket of buckets, right?
You just eliminate the word new, how it works so?
No. You need the new because you're allocating memory for this thing. And that's kind of what the new command does.
Because otherwise you'd be trying to reference something that didn't exist yet because you
Right.
hadn't created it by calling it new.
If in this case it's just going to be an item list, that it's just going to be a container for an item list, and you can say go to this item list and get this item, but there's nothing to go get there because it's just a pointer to hold something. There's nothing there yet. That's what this looks like. With this, we're creating that pointer, and we're saying, and create a new object of this type and put it in there so we can access it later. So this is creating a list of strings, and then in our Unity editor, we can see that we now have this item list, and it's we can fill it right here. We can define that we want 5 things to be in this list, and we can put strings in here and fill it up. So we'll do a quick test. This is where we can use a loop. It's called a for each loop, and we'll say for each string item. So this is defining a new variable item, which is of type string, and the in keyword is saying where we want to get those items from, where we want to get those strings from. So this is basically the same as a for int I equals 0, I is less than item list, item list dot count I plus plus. And then you'd access each item list I. We'd say like a debug log. Okay. This is the same, except we're basically creating a new variable to store that item list I in, so then we can just access it like this. It's a bit easier way to iterate over a list. It's not available for all lists. For a lot of lists you're going to be using, it's available. You may still have to use this for loop at times, especially if you wanted something like the index of the list item, or if you're keeping track of other things. But for now, just imagine that the for each loop is going to be what you want to use for iterating through a list. Does that make sense? The for each?
You don't have to know how many items there are in the list.
You don't have to know how many items there are on the list, and you don't have to do any. You don't have to write the extra code of a for, and it's just a way to say, for each item in this list, do this thing.
Which in this case, it's just print the name of the item.
Just print the name of the item. We could, well, we are going to in a little bit, for each item in the list, create a new button with that item name as the button name. Okay. For now, we're just doing a quick test to see what it looks like. We can see, for now, we'll just we'll put cubes in here. We'll create some new prefabs in a little bit, but so we can see that we get this cube 5 times, because in our start method we went through and said for each string in this list, print the string. Technically, we don't have to do.
Does it matter if you're dragging or typing? Or can you drag the objects into that element, or do you just type?
No, you can't, because they're not strings.
Oh, okay.
And this is a list of strings, so it's not going to accept something that's not the same type. Oops, I did that one. So if you modify things while Unity Editor is running, they're going to be reset as soon as you stop running. You may have noticed this already. But here's a little trick. If you find out that you went through and you modified something during runtime, you're like, I'd really like to save that, or if, say, if you're running it and you want to position something just right, in this little gear icon up here, you can do copy component, and it's going to copy the component with those values. And then when you stop playing, you can do the gear icon again, and you can do paste component values. So now it's gonna save those component values from runtime and then paste them back in. So that's really useful, especially when you're dynamically creating something and you want to get it positioned just right. You can copy that. You can copy the transform and then paste the transform values back when you get back to the editor. So now if we run this, it's going to say cube 0 or cube 1, 2, 3, 4, just like our list here. Starting to look good. I feel the infrared lasers. That one's not running now. Oh, no, it just picked it up. We're good. All right, so we have an item list. In that list, we're going to store prefab names. And for each prefab name, we want to instantiate a new button. And so we have our button prefab here under resources. So for each item in that list, instantiate, and then we're going to load the item with resources. Oops, resources.load of type game object. And it's just it's directly under the resources, so it's called button. If you want, so as you proceed with Unity, you'll want to start to get a little more organized. For example, creating a new folder under here. We'll call it UI prefabs. I have to put that button in there. And then when we instantiate it, we do it like this. Whoops, other way. / So now we're referencing resources / UI prefabs / button. And that'll help once we get more things in here, like we have a new folder, which we can call rename game prefabs, something like that. Okay. All right, so for each of those, we want to spawn a new button. Think that's going to work like we want it to? We're instantiating a new button here, right?
But are we telling it where we want it instantiated?
Yeah, we're not. So when we hit play, it's just going to create all these buttons, but a button has to be underneath a canvas object to show up, right? So we can fix that by our button list, for example, is where we want to, the button list is what we want to be the parent of these buttons, right? So we'll modify our script to take a transform. Called button parent. Remember, the transform is just a position. It's an item in the hierarchy, essentially. It's a position, rotation, location. But it's also a way to reference an object. The parent-child statuses are all part of the transform structure, not the game object structure. So we want to reference a transform, and that's we can do that here. So now our spawner should show the button parent there, and we're just going to take our button list and drag it in to there.
So button parent is just a variable that you just created. It doesn't, Unity or Visual Studio, it doesn't know what button parent
It's not a special, we're not using it yet. We've defined it, we've set it, and now we can use it here. We can say this instantiate returns a game object. So I'll have my button, and then we'll say my button dot set, dot transform, because we need to access the transform to set the parent. Set parent is equal to button parent. Okay. You technically can do this, but Unity's going to say that's kind of frowned upon. They don't like to set it like this because they have other stuff they like to do when you assign the parent, so they want to make sure that stuff runs, and it's harder to do when it's set up like this. So you can just, it'll complain and it'll put a warning in somewhere in here once it compiles, maybe, or once we run it. Is being set with parent property, consider using set parent method instead. So it'll supply a warning to you about it if you forget. Likely because at some point they're going to phase out that, so you can't assign it like that anymore. But
Can you scroll back up so that we can see? Yeah.
yeah. So I've set this button parent, and I put in the lists, our panel list, as the parent. And now we're going to create a new button, and we're going to set its parent to be that button parent, which is the list. So if we looked at that here, I'm guessing something happened with our scale there. Yeah. So you can see our buttons are giant sized at the moment. Sometimes Unity does this depending on how you've configured the scale settings. So I think we must have saved this prefab outside of this scale environment. So let me see here. An easy way to fix it is to say my button transform local scale equals vector3.1. So that'll just set the scale, because the scale was being set to compensate. So it was saying, I've created this object and its scale is at 1. And now it's like, oh, I'm being instantiated inside of a canvas that has its scale set to 0.005. So I need to compensate for that by increasing my scale. And that's just the order of things, how they get created sometimes.
Why would it increase its scale if the canvas is decreased?
Because the button is this size, the size of my hand, right? And you've created it and you're putting it inside of this little tiny object that's been scaled way down. So when the button is added there, it's going to try and keep its same relative size. It's going to try and appear the same. So it has to scale, instead of being this little tiny button, it has to scale itself way up to be the same size. And so that's what happened there. But we want to set the scale equal to 1, and that'll zoom in here. So now we see that we've created 5 buttons for the 5 things on our list.
And vector3.1 just tells it to refer back to the canvas size.
Now vector3.1 sets its scale to 111. And because of the hierarchy here, that's going to say everything underneath me needs to be scaled down. The hierarchy, the child position, rotation, and scale is dependent on its parent and its parent and its parent. So that translates down to everything underneath canvas should be a scale of 1, and then the canvas is going to be what controls the scale of everything underneath. Okay. Now we have 5 buttons, but they all say button. so it's not really clear which one's which, right? And so the thing that controls a button's text, Nebraska. The thing that controls a button's text is this text element underneath. That's where the text is. And we can access that, even though this game object is referencing this game object above, and underneath is the text, and that's the text object underneath has the text component that we want to access. We can do this myButton.get component in children. So we can look for a specific component in the children of this game object. And we're looking for a text object. And right now we need to, a lot of the time you can do this show potential fixes when it's complaining at you. And in this case, it's because it's not using the Unity UI, Unity Engine UI. So it's not sure what text item you're talking about. And it's called fully qualifying. So you can either fully qualify with Unity Engine UI text, or you can add a using statement. UI. Then it knows that that's the text class you're talking about. And this is going to return a text, so we want to create a text. My text equals. And then the text of that text component is called text. So now we can use our item here. So we're creating the object, we're setting its parent, we're setting its scale, and then we're retrieving the text component in one of its children, which we know is there because we created the prefab. And then we're setting the text of that text element, which is, this is the child. Come on. This is the child, this is the component we're retrieving, and this is the text value. So now we have our cube 1, 2, 3, 4. And we have a dynamic UI. So now you can create UIs that, you can have usernames or properties that they've set themselves, and you can show them in game like that. They don't do anything yet. That's the next step.
So because you've created it dynamically, now potentially you could take that same set and apply it somewhere else with a bunch of different values.
Yeah,
you
so
would have to recreate it.
So let's do that here. We can just copy this spawner object. We can move it over here. And in this guy, we'll say, like seer 1, 2, 3, 4. So all we did is make a copy of that spawner and change the items in this list. And now we'll get 2 UIs. One of them with, that's just the list items that we set up here. We're just iterating through each one and setting the text of it. So, so the tricky part, let's remove that extra guy. Tricky part is, so up until now you've been going into that button and you've been setting this on click event, right, to control the action of when it's being clicked. And we're going to configure that in a script instead. First, let's take a little break, and I'll get this working, and we can see what it looks like in game as well as just in the editor. But, so 10, 15 minutes or so.
Yeah, yeah.